So, part 3 of this exam, like hardest exam questions, and here the questions we're going to be doing are as follows. This question 1, a binomial series question. Question 2, which is a sort of differentiation question. Question 3, sort of integration / differentiation question. And question 4, which is like a vector question. So we're going to go through those today, and I'll put timestamps for where all these sort of harder questions, the time in which we do them, in the description, and I'll put the link to this sort of question and answer sheet which I made. So I've got all the answers, my answers to those 4 questions, but we'll just start straight away here. And so the first question here is the binomial expansion one, and we have this expression here, 3 minus 2x times 1 plus x over 2n, and it says the coefficient of x is 7, so that's important, and find the value of the constant n, and hence find the coefficient of x squared. Well, because we know that the coefficient of x is 7, we'll be able to find a expression, an equation to solve n. So we're given, we know that if we look at our formula sheets, we have this binomial expansion equation, plus n1 a to the n minus 1 b plus some more stuff. And so let's just first expand this part, and that's going to be, well, an is just 1 to the n plus n1, and then our b here is x over 2, so we get 1, which is our a, to the n minus 1, and then we get x over 2 to the 1. And that's only the 2 terms we're interested in, because we're only worried about the coefficient of x, and when we times these in, these are the only 2 terms which will produce a coefficient of x. So you'll see here, so when we do this, now we're looking at this one. Actually, first we can simplify this. So this 1 to the power of n, so that means 1 to the power of some number which we're trying to find, is 1 no matter what. And this is n1, which is actually n. And if you just think about it, you have this equation also on your formula sheet, which is this of n minus r factorial. Well, if r is 1, this becomes 1, and this becomes 1. And 1 factorial is 1, so we can just get rid of it. And then it's just n factorial over n minus 1 factorial. Well, if you think about it, let's say if n was 3, you get 3 factorial over 2 factorial, and that's just equal to 3, because you got 3 would be 3 times 2 times 1, and this is 2 times 1, and you can see no matter what it will be, you're always going to get n. So this actually equals n, and I suggest you understand that if you didn't understand my explanation there. Again, 1 to the power of n minus 1 is just 1, and then this is x over 2. So now we can look at, finally we can look at this, times 1 plus x over 2 to the n. Well, the 2 factors which will contribute to our x, coefficient of x, will be our 3 times this part, so we'll get the 3 times our nx over 2. We can just rewrite that as nx over 2. And we also are negative 2x times our 1. So that will give us 3 over 2n x minus 2x. And that equals, so if we factor out an x, so in the expansion, this is the coefficient of x, and we know that the coefficient of x is actually 7, so we can just set that equal to 7. So this gives us 3 over 2 n equals 9, which gives us 3n equals 18 and gives us n. Therefore, our n equals 6. So now we found that n is 6. We can then find the coefficient of x squared here in the expansion. So we have 3 minus 2x times our 1 plus x over 2 to the 6 now. Well, again, let's address this first part. So when we expand this, we get 1 to the 6 plus 6, 1 from our binomial formula times 1 to the 5 times x over 2 to the 1 plus 6 to 1 to the 4 x over 2 to the squared plus some more stuff. And we're only interested in these first few terms because we're only interested in the coefficient of x squared. 1 plus, this will be 6 times x over 2, which is 3x. Plus 62 will be 15 of x squared over 4 plus some more stuff. So then if we want to look at this expansion, we'll get 1 plus 3x plus 15 over 4x squared plus some more stuff. So the only two things that will contribute to our x squared coefficient will be the 3 times the 15 over 4x squared and the minus 2x times the 3x. So we get 3 times 15 over 4x squared, and that plus minus 2x times 3x. So we get 45 over 4x squared minus 6x squared. So if we go to our calculator, let's do 45 divided by 4. And that minus 6 equals, let's look at it in a fraction, is 21 over 4. So this equals 21 over 4x squared. So our coefficient, you can just write coefficient of x squared in the expansion of this, is 21 over 4. And that's your answer right there. Cool. Let's move on to the next one. So we're given a curve here, such that, so it's dy by dx equals 2 over a minus a half plus ax minus 3 over 2, where a is a positive constant. And then there's a point that lies on the curve, which is at a squared 3. Find in terms of a the equation of the tangent to the curve at a. Well, so this is the differential equation of the curve. So if we want to find the tangent at a, we simply, so let's just go I, because this expresses the gradient at any point on the curve which you'd like, any x coordinate. So if we want the gradient at a, we simply substitute in a squared here. So we get 2 over a squared to the half plus a over a squared to the 3 over 2. And that gives us 2 over a squared plus 1 over a squared, which is 3 over a squared. So therefore the gradient of the tangent curve, so the gradient of the tangent line, sorry, at a is 3 over a squared, and a point on that tangent curve will be a squared 3. Because if you think about it, you've got some curve, and this is a, and this is your tangent curve. The gradient of the curve is the same as the gradient of the tangent line. So therefore the gradient, the equation of our tangent line is y minus, this is from the y minus y1 equals mx minus x1. So we get y minus our y1, which is 3, and our gradient, which is that, times x minus a squared. So y minus 3 equals 3 over a squared x minus 3. So we get y equals 3 over a squared x. So that's the equation of our tangent line at A. So that part done. Find the equation of the curve. Well, if we have dy by dx equals 2 over ax to the negative half plus ax to the negative 3 over 2, ax to the negative 3 over 2, well, that means we can take the derivative of both sides, because we're trying to find the equation of the curve. And that just becomes 2x to the half over a times down plus ax to the negative a half over negative a half plus c. So that's our y. And then we can just simplify this. We get 4x to the half over a plus a minus 2ax to the negative a half plus c. Yep. Cool. Sorry, I'm just having like a random mind blank. Y equals 4 over a x to the half minus 2a x to the negative a half plus c. And now we can find our plus c because we have a point on this curve. So we substitute in the point a squared 3. Pretty sure that was it. Yep. So we substitute that in. So we get 3 equals 4 over a, and then a squared to the half minus 2a. This is over a squared to the half plus c. You get 3 equals, well, this is a, so it'd be 4. And again, this is a over a, so minus 2 plus c. And that's just 2. So c equals 1. So therefore, the equation of our curve is 4 over a x to the negative a half, no, x to the half, minus 2ax to the negative a half, plus 1. Then it gives you here, it says that now you're given another point, so you're given point B. So this is I. You're given point B, which is at 16.8, which also lies on the curve, and this wants you to find the value of A and then find the distance AB. So this is, oh my god, I forgot it, is 16.8. 16.8. So this lies on the curve, so we can just substitute this in and find the value of A. So this would be 8 equals 4 over a 16. The square root of 16 is 4. It's times 4. Minus 2a divided by, again, the square root of 16, which is 4, plus 1. So let's just go 8 equals 16 over a minus a over 2 plus 1. You can take the 1 over, and you get 7. And we get 7a equals 16 minus a squared over 2. So we get a squared plus 14a minus 32 equals 0. And a equals then minus 14 plus or minus the square root of 14 squared minus 1 minus 32. All over 2, 1. And if you figure that out, which I did before, you get a equals 2 and a equals negative 16. And obviously it can't be this one because a is a positive constant. So our A is 2. So that means that our point A, because it's at A squared 3, is then 4, 3. And our B is 16, from up here, 16, 8. So if we want to find the length AB, well, we simply just do our 16 minus 4 squared plus 8 minus 3 squared, which is equal to the square root of 12 squared plus 5 squared, which is the square root of 169, which equals 13. So our AB length equals 13. So question number 3. And in this question, we have an equation. We're given an equation which is y equals kx minus 3 to the power of negative 1 plus kx minus 3, where k is a non-zero constant. Find the x-coordinates of the stationary points in terms of k and determine the nature of those stationary points. Well, we've sort of seen these things, similar questions many times, but they're introducing a k element, which makes it a little harder. But we know that stationary points occur when dy by dx equals 0. So our dy by dx equals, will also be minus k, kx minus 3 plus k. Where does that equal 0? Well, we can divide through by k and we get a minus 1 over kx minus 3 squared plus 1 equals 0. And then we can say we have kx minus 3 squared equals 1, k squared x squared minus 6kx plus 9 equals 1. Take the 1 over, we get plus 8 equals 0. Right, so then we can then figure out our x coordinates. So we get 6k plus or minus the square root of 36k squared minus 4k squared times 8, which is minus 32k squared, all over 2k squared, and that's just 4k squared. And when we square root that, we get plus 2k, plus or minus 2k. So our x is either 8k over 2k squared, which is 4 over k, or our x is equal to 4k over 2k squared, which is 2 over k. So our stationary points occur at x equals 4 over k and x equals 2 over k. So those are our stationary points. Now if we want to determine the nature, because it also wants us to determine the nature of those stationary points, now we have to find the second derivative. We know that our first derivative is minus k, kx minus 3 to the negative 2 plus k. Just double check that. Yep. So therefore our second derivative will simply be, well, that's just 0. This will be 2k to the k, 2k squared to the kx minus 3, like this, which is 2k squared over kx minus 3 cubed. So then the nature, so if we want to see of the stationary point at 4 over k, well, the nature of that stationary point, we just substitute it into our second derivative, and we get 2k squared over, and then if we substitute 4k into here, you can see you're going to get, the k's will cancel and you'll get 4 minus 3, so you actually get 1 cubed. So that's 2k squared which is, because k is a positive constant, is greater than 0. So therefore our x equals 4 over k, stationary point is a minimum. So that's the minimum one. And then you can do the same for the second one, which is, again, we substitute that in, and we get 2k squared. This is when x equals 2 over k. And then we substitute 2 over k, and then we get 2 minus 3, so you get minus 3 minus 1 cubed, which is minus 2k squared, which is less than 0, because k is greater than 0. So therefore our x equals 2 over k, stationary point is a maximum. Cool, so then we've determined the nature of those stationary points. So we've determined where those stationary points are in terms of k, and also the nature of those stationary points. And that's 7 marks right there. Okay, so let's do II now. Okay, so now we're given this curve. So II, we're given y equals x minus 3 plus x minus 3. I think that was it. Yep. And it wants us to find the volume when this is rotated around the x-axis. Well, if you've seen my integration video, our small dv here is pi y squared dx. So if we want the total volume between x is 0 and x is 2 of that rotated region, then our volume total will equal to between 2 and 0 of y squared dx. So let's find our y squared. It's just simply x minus 3 plus x minus 3 here times, squared. So that gives us an x minus 3 to the negative 2. And you'll get a plus, well, you'll get a plus x minus 3. Well, okay, we can write this out. X minus 3 to the negative 1, x minus 3. You get 2 of those. And then you'll get plus x minus 3 squared. Well, these just cancel each other out. So this is just a 2. So actually you get x minus 3 to the negative 2 plus x minus 3 squared plus 2. Okay, so then our total volume would be 2, 0 of x, remember our pi here, minus 3. And then if we integrate this expression, we get x minus 3 over times down by the power is negative 1 plus x minus 3 so that'll be minus, and we can say it'll be minus 1 over x minus 3 to make it easier. So we get pi of, when this is 2, you get 1 plus 1 minus a third plus 4. So this is 5 minus a third for the 2, and then that minus 0 is 1/3. If you plug 0 into here, you get 1/3, and you get plus minus 3 cubed over 3 plus 0. And if you put all that in your calculator, you should get, I did this before, 40 pi over 3. So that's your total volume. Okay, then the final question here is a vector question. And so let's look at this. So relative to the origin, we have 2 position vectors, p and q, which are p and q lowercase respectively. And the point r is such that PQR is a straight line, with q as the midpoint of PR. Find the position of r in terms of p and q. Well, let's just get an idea of what this is saying. So we have this point P, we'll say the origin is like here. So that's our OP, and then we have this point R, stays over there, and then we have in the midpoint between P and R we have this point Q, and this vector here is Q, and this vector here is P, and this is O. So it wants us to find OR in terms of P or Q. Well, OR is simply minus OP plus PR. So OP plus PR, and PR is equal to, so OP plus PR, and PR, because Q is the midpoint, is equal to 2PQ. So PR is equal to 2 times this vector PQ, because it's at the midpoint. So if we find PQ in terms of P and Q, and we already have this, OP is just P, so OP is P plus 2PQ. Then, so PQ, if we look at the diagram, is equal to minus PO plus OQ is equal to minus OP, so minus OP, sorry, plus OQ, which is OQ minus OP, which in terms of P and Q is simply just Q minus P. So therefore our OR is equal to P from here plus 2 times Q minus P. So that gives us P plus 2Q minus 2P. So it equals to 2Q minus P. So that's our OR in terms of P and Q. Okay, and then finally B. Here we're given a vector, let's call it V, of 6AB. So I'm just rewriting it in vector form because I always like it in this form instead of the IJK, and has a magnitude of 21. So the magnitude of this vector equals 21. And then we get another vector here, I'm just calling it U, 3, 2, 2. And it says that these two vectors are perpendicular to each other, which means that their dot product is 0. And it says it wants us to find the possible values in A and B. Well, we have an equation, 2 equations relating A and B, so you can find A and B from that. So let's just deal with this one. So V dot U equals 6AB dotted with 3, 2, 2. And that equals 18 plus 2A plus 2B, and that all equals 0. So we get A plus B equals minus 9. So that's one equation. The second equation can come from this, which is, we can say, because that equals 21, we can say that, you know, this squared equals 6 squared plus A squared plus B squared, and that's just 21. So 21 squared minus 6 squared equals A squared plus B squared. So we just go in our calculator and we do 21 times 21 equals that minus 36 for the 6 squared. So we get 405. So 405 equals A squared plus B squared. So our A squared plus B squared equals 405. So that's our second equation. And then, so now we can so we can say that B from our first equation equals minus 9 minus A. So our A squared plus B squared, we can just substitute this B, minus 9 minus A, to find our A. So a squared plus 81 plus 18a plus a squared equals 405. So that gives us 2a squared plus 18a, and then 81 minus 405, 324 equals minus 324 equals 0. We divide through by 2. 9a minus, I just don't want to get it wrong. Divided by 2. Minus 162 equals 0. And then that's a minus 8. So 8 times, so what would it be? The 18 times 9 is, okay, so it'd be a plus 18 and a minus 9 equals 0. So your a equals 9 and your a equals 18, minus 18. And if you simply plug that back into your equation 1, you get minus 9 minus 9. So you get minus 9, which means this b will be minus 18, and this b here will be minus 9 minus 18, which will be 9. So that's your possible values of a and b.